Good morning, everyone. We are Group A and we're here to present a topic given to us, carbon theory. So on today's agenda, we're going to be looking at the introduction, the structure, allotropes, types of carbon, and then the uses of carbon.
Structure and allotropes of carbon. Carbon structure. Carbon has 4 valence electrons. It can form 4 covalent bonds with other atoms, including other carbon atoms. This bonding ability allows carbon to create different structures called allotropes.
So before we start with the major types of carbon, firstly, we define allotropy. An allotropy refers to the ability of carbon to exist in various forms in the same physical state. So now the major types of carbon, we have bimond, each carbon bonded to 4 others in a 3D structure. Graphite, carbon atoms in flat layers, which are hexagons. We have graphene, single layer of carbon atoms in a hexagon sheet, and amorphous carbon, no clear structure, e.g. charcoal or soot.
So we have the types of carbon with examples. We have 2 types of carbons which exist sometimes in a solid state. So we have crystalline carbon and amorphous carbon. So crystalline carbon has a well-organized structure, meaning it has a solid shape. So examples include diamond, graphite, fullerenes, and graphene. Then amorphous carbon has no definite shape or structure. So that means it can come in any shape as you like, or an irregular shape. Some examples include charcoal, lamp-black, and coal.
So now we're going to be talking about diamond versus graphite. We have features of graphite and diamond, the structure, the hardness, conductivity, and uses. So for the structure, graphite is a 3D tetrahedral and has strong bonds, while diamond has layers of hexagons. The hardness of graphite is very hard, and the diamond is soft and slippery. Conductivity. Graphite does not conduct electricity. Yes. Diamond is very hard. Sorry, graphite is soft and slippery. The conductivity of graphite is that it does not conduct electricity at all, and diamond conducts electricity. So diamonds are used for cutting tools, and it can also be used for making jewelries. And graphite, you can find it in your pencil leads, in batteries also.
Let's look at an industrial process titled disruptive distillation of coal. This process is the heating of coal in the absence of air. To break it down.
All right, stop. Thank you very much. Before you continue, for the entry into the subtopic. So before you go on, we're going to ask you a question. Then if you have a question, we'll also ask you a question so that we can understand that based on the presentation.
Okay. All right, so before we move to the other subtopic, I'd like us to ask each other questions. You ask them questions and then they'll ask you questions so that we can clarify any misunderstanding. All right, so class, do you have any question for them? Okay.
Why are the electrons on the, what is valence?
Okay, she said, what is valency? You're talking about electrons on carbon, right? So what does it mean?
Okay. So valence electrons are electrons that are found on the outermost shells, and they are the ones that have the tendency of accepting and giving out electrons.
That is correct. Do you have any other questions? Do you understand? Okay. Any other question?
What is allotropy?
Okay, you mentioned allotropy. So he's asking what is allotropy?
So allotropy is the ability of carbon to exist in various forms in the same physical state.
Can you give us examples?
We have graphite and diamond.
Graphite and diamond. Okay. So she said allotropy is the ability of what carbon to exist in different forms, but in the same physical state. For example, diamond and graphite, they are both forms of carbon, right? But then they have different structures, just the way they describe. They have different structures, about one conducts electricity while the other one doesn't conduct electricity. Do you understand, Kamsi? We still have another question.
Why are they different? Why do they have different physical properties?
So why do they have different physical properties?
So diamond, obviously diamond is shiny and they are definitely two separate components itself. So the physical properties are different because they have like their own unique features.
Okay. So let me explain that for you. So if you look at diamond, in the beginning, they gave you the shape of the diamond and graphite. And if you look at the shape of diamond, you say diamond has a tetrahedral shape. The covalent bonds are bonded and then they form like, the shape of diamond, like a pyramid, right? But in that of graphite, there are spaces, they form layers. They lay over on top of each other. So because they have this different spatial arrangement, they have different physical properties. Do you understand? All right, thank you. Any other question? Any other question? All right, you should ask them question. Were they listening? Ask them, were they listening? Let's see.
So earlier I spoke about conductivity of diamond and graphite. So which one conducts electricity and which one doesn't?
Okay, Sarah has not spoken.
Diamonds conduct electricity while graphite doesn't conduct electricity.
Is she correct? No, she should say it again.
Oh, graphite conducts electricity while diamonds don't conduct.
Is she correct now? Diamond does not conduct electricity. It doesn't have free mobile ions. But graphite that doesn't have that solid arrangement, it has free mobile ions that enable it to conduct electricity. Do you understand? Okay, ask another one. Ask them for this. Do you have any question? Okay.
So I want someone to mention the two types of carbon with one example each.
Two types of carbon. Fruitful has not spoken. Let's be fruitful.
We have the crystalline carbon and the amorphous carbon. For crystallized carbon, we have diamond, and with amorphous, we have graphite.
Okay, graphite. Are you sure? Is it correct?
Charcoal.
Okay. All right, now listen. You said we have two types of carbon. We have crystalline carbon and amorphous carbon. Now, your amorphous carbon can also be known as non-crystalline. When we say crystalline, that's why you have diamond. Even though graphite is not like diamond, it still has shape, right? But in the case of the amorphous carbon, they're shapeless. That's why I call this amorphous. Do you understand? And under amorphous carbon, have you seen charcoal before? You've seen charcoal. You've seen carbon suits. Okay, I don't know how many of you use wood in your house. Usually, if you go to see your grandparents in the village, if they're using firewood, there's usually this black thing that used to fall from the roof. So that is carbon suits. We call it carbon black. They use it in making polish. So these are the different types, the amorphous and then crystalline. Any question? Is there any question? All right. So can we continue to the next subtopic? Okay, thank you very much. Please, you can go ahead.
As I said earlier, we will be looking at an industrial process called destructive distillation of coal. This is a process where you heat coal in the absence of air. As a result, it breaks down into useful chemical products. For example, we have coal. Coal is a solid that can be used as a fuel and a breaking down agent in smelting iron. We have coal tar. It's a sticky substance that can be used to make dyes and drugs. I have other examples like coal gas and ammonia solution. Now, as I said earlier, each product has industrial use in fuels, chemicals, and fertilizers.
We're looking at the classifications of different cokes. So we have types of cokes, which are foundry coke, which are used in like metal boundaries. It can be used to make like metallic products such as cars, tin cans, containers, and other metal products. So our blast furnace coal is in iron and steel making. So this is used in iron smelting where you have like a blast furnace. Where you have like a blast furnace and you subject hot air into the coke. This separates the iron ore impurities. And then we have domestic coke used for heating. So now, uses in general, we can use them as for in metallurgical processes, like as I said before, metal making, and to reduce metal ores in blast furnace, which is part of blast furnace coke.
Diamonds or crystalline carbon. We can use diamonds for cutting tools. We can use diamonds as glass cutters or drills. We can use diamonds to make jewelries, and diamonds can also be used as heat conductors in electronics.
So we can also see a picture of how diamonds look like. We can see that they are shiny and and they have a definite shape, like a hexagon-ish shape. So now we have graphite, or also known as crystalline, also a form of crystalline carbon. So like I said earlier, graphites are used in making pencil leads. We can see it looks, if you touch a graphite, it's going to have like a black stain on your hand. So it can also be used as lubricants for machines, electrodes in batteries, and electrolysis, and brake pads and lining.
So we have amorphous carbon, as I explained in the types of carbon. So this first example, it could include charcoal, which is used for cooking. As in the old primitive days, charcoal was the main source for cooking. Then you also have drawing. Charcoal is also used in making some pencils. They're called charcoal pencils as well. Then it's also used for purifying air and water. So we have carbon black, which is used in making tires, inks, and paints. And then activated carbon is used in making gas masks and water filters. Thank you.